With the children of Britain, as early summer draws near, a cloud gathers.
To Orly Airport, a French airliner brings a cargo of sadness.
Poliomyelitis, believe many knowledgeable persons, may reach epidemic proportions.
The patient's chest and breathing muscles become completely paralyzed. The iron lung is the latest scientific instrument to help in the cure of infantile paralysis.
I sincerely hope that my gift will be the means of saving many valuable lives.
Polio, or as it's fully known, poliomyelitis, is a viral disease that's actually been with us since antiquity. If you look, there are examples of Egyptian imagery from ancient Egypt, which show what seem to be healthy people, but with perhaps one withered limb or walking with sticks. But for most of our human history, it's just been in the background, a sort of endemic disease. But during the 20th century, it became an epidemic. So how do you catch polio? Well, you can catch it directly from another infected person, but it's really a disease of poor hygiene and poor sanitation. So dirty water, food can be contaminated, it can be passed quite easily. Most people who got polio would never know they actually had it. About 3/4 of the people had no symptoms at all. Some people may have a sore throat, headaches. It would clear up after a couple of weeks. If it got more serious, then it could affect muscles, and that could result in paralysis of particular limbs, which could be temporary or could be permanent, and that could affect the development of those limbs. It's very much a disease of childhood, so most of the people who were catching polio during the 20th century were under the age of 10. But it could affect adults as well, and often quite seriously. Because if it goes beyond that sort of very benign, almost early stage, where it might just be sort of minor symptoms, and gets into the central nervous system and causes paralysis. Some of those muscles that could be paralyzed are the muscles in the chest, the diaphragm, the muscles in between the ribs, the muscles responsible for breathing. Until the late 1920s, patients with polio who were left unable to breathe were particularly vulnerable, and there was often not a lot that could be done. But in the late 1920s, Philip Drinker, who was an industrial hygienist working at Harvard University, along with a colleague, Louis Shaw, who was a physiologist, they started looking into ways to resuscitate people who had breathing problems. And although this device behind me is very much linked with polio, much of that initial research was funded by a gas company because they were also looking at how to revive people who'd been asphyxiated by gas. And the result of their research was what we could call the first iron lung. The object behind me is a later design, but it's called the Drinker iron lung, named after the man who invented it. So Drinker and his colleagues developed their first iron lungs towards the end of the 1920s, and initially they experimented using animals. But in 1928, they had the opportunity to have a human subject. And this was an 8-year-old girl who arrived at Boston Children's Hospital in Massachusetts, unable to breathe. And she went in to an early version of the Drinker iron lung and was kept alive for 5 days. And sadly, she did die of pneumonia. But that was unconnected to the iron lung, which has very much proved its worth. And they started being distributed around the country. This one example here was actually made in Britain by Seba Gorman in 1931, and they were the sole makers of Drinker designs in this country. It's a slight variation on the earlier Drinker lung. It's got a lot of additions in terms of portholes to give access to the patient. We've got windows here that you can look in. But how does the iron lung actually work? So although these machines became known as the iron lungs, a more accurate term for them is a negative pressure ventilator. And that gives a clue to how they work. This is basically a metal box into which a patient would be put in. The only part that will be outside of the box is their head, which will be coming out at this end. And underneath are the remains of a pump, and you can see the bellows there. And a tube would connect to this end, where air could be pumped in and pumped out again. And once air was drawn out of the box, pressure would reduce, and a person who was otherwise unable to breathe, their chest would expand because of the pressure change. So air would be forced into their lungs. As pressure was increased again with the pump, the air was forced out of your lungs. So they were artificially breathing within the iron lung. And that's the sound of the pump and the whoosh of the air became a sort of reassuring sound of somebody breathing. Drinker iron lungs undoubtedly saved a lot of lives. But they were heavy, they were expensive. It's said that in the 1930s, an iron lung like this would cost the same as a small suburban house. We're sort of talking tens of thousands of pounds in today's money. And they were in great demand, and other manufacturers started to look at how you could produce cheaper iron lungs, lighter iron lungs, ones that could be more easily transported. But it wasn't just companies making iron lungs. Such was the demand and the need for iron lungs that some individuals just made their own. Well, believe it or not, this object next to me is also an iron lung. And it's essentially a homemade iron lung. It was made in 1938 by a Dr. Harries, who was a doctor at the Cardiff Isolation Hospital in Wales. And he'd heard about iron lungs, and he couldn't really wait for the hospital to get their own one. So he made one. And although it looks very different to the drinker iron lung that we just looked at, it fundamentally does the same thing. Not long after he made it, there was a record that a 10-year-old girl came in with chest paralysis because polio was epidemic during the 1930s, and she was kept alive in this machine for enough time to recover. It's made from odds and ends, really. At the base, you've got an old bed frame. In the middle, you've got the equivalent of the metal cabinet from the previous iron lung. And the patient would go inside at this end. There's a hole for the head there. It may be made from an old cupboard, we're not sure, but it was made airtight because keeping an iron lung airtight is essential to be able to sort of change the pressure within it. And how he changed the pressure here was with this massive pair of bellows on top. And this is a blacksmith's bellows that would normally be used to heating a forge. But on top here, it was activated by this long handle, which is down here. It's now separated from the object, and it would be worked up and down to sort of create a pressure, negative, positive, to force the lungs to breathe. In terms of powering iron lungs, electricity is essential, and electricity was essential for the sort of long-term success of iron lungs because it's a machine that it needs to keep going. Not long after this homemade version was made, Cardiff Hospital did get their own production-made iron lung powered by electricity. But they didn't just simply throw this one away. It was kept as a reserve, and apparently it was used into the 1950s. It's a super cheap iron lung, particularly compared to the drinker. But cost is really an issue when it comes to iron lung production. So the drinker was expensive, it was heavy, it was quite difficult to export. So what was needed was something in between that was cheaper, lighter, easier to make, something that could reach more people. And a low-cost solution was created by two Australian brothers, Edward and Don Both. And it's a Both iron lung that we're going to look at next. This is the Boff iron lung. It looks very different to the previous iron lung, the homemade version, but there are certain similarities. Unlike the drinker iron lung, this cabinet is made of wood. It's made of plywood, which makes it much lighter and much cheaper. Now, these iron lungs were first designed in Australia in the late 1930s. Edward Boff, who was a prolific inventor, he was known as the Edison of Australia, and he travelled to the United Kingdom in 1938 when there was a polio outbreak ongoing, and he actually made iron lungs to this design, and they caught the attention of William Morris, but not that William Morris. This William Morris, better known as Lord Nuffield, was the owner of the Morris car company, which during the 1930s was probably the biggest car company in the country. And he was a very wealthy man, but he was also a philanthropist. And he decided that he was going to finance the production of artificial lungs based on this design. And he gave a part of his, the Morris car works in Cowley outside Oxford for the production of them. And in the coming years, he produced several thousand. They were presented to various hospitals within the UK and also parts of what were then the British Empire. The particular example we have here was presented to Derby Royal Infirmary in 1938. And it was one of many that were given away, essentially, by Lord Nuffield to various hospitals in the country. And they became known as the Boff Nuffield iron lung. And although a lot of patients only spent a few days in an iron lung, maybe a few weeks, and many serious cases recovered once they got over the critical phase early on when they really were unable to breathe. Some patients never fully recovered and could spend years in an iron lung. But even then, with physiotherapy and various other treatments, some level of breathing could often be brought back and they could spend short periods of time outside the iron lung. The appearance of a vaccine in the 1950s changed everything. Within a few years, mass vaccination campaigns had drastically reduced the numbers of cases. The iron lung in many ways became obsolete. So iron lungs, be they like the machine behind me, mass produced, well distributed, or like the homemade version earlier, or the original drinker device, very much consigned to museums these days. But their legacy is, I think, the beginning of the idea of an intensive care unit, where you have a very specific technology, you have a lot of medical staff, and you have a particular area of the hospital where very sick patients are being looked after. These big machines are certainly not pretty. They could be very noisy. People found them frightening. They could be mass-produced or they could be cobbled together from bits and pieces. But in the fight against a terrifying disease that was killing thousands of people during the 20th century, they undoubtedly saved many lives.